And we're going to just pick up in section 2 and talk about measures of center. Okay, so chapter 2 is all about frequency distributions, histograms built off of the O's, things we're going to deal with that. We're not going to depart from having frequency distributions. Those are, just part of statistics. You're going to have those. We're going to work on measures of center for data sets, samples, populations, things that we're given. Okay, in Algebra 2 or Algebra 1, 7th and 8th grade math, you may have heard them called measures of a central tendency. Okay, measures of central tendency was what we sometimes called them. One of those measures of central tendency was the mean. Okay, and the mean that we were talking about then was the arithmetic mean. Which is just the average. We all know that. Okay. Now, what do we know about the mean? Things we know about the mean, depending on what we're given. Means from a population. Very less than other measures of center. Okay, so if it's a mean from a population, it varies. When I say varies less, that means it doesn't fluctuate as much as some of the other, measures of center do from that population. Okay, so from a population, the mean varies less than some of the others do. It uses every data value, which is a plus and a minus to it. Because it uses every one, that's great. That means we've got every one. The bad part of that is uses every one, so you have to put in every single one. Okay, so a mean from a population it's using everybody, which is great because we get a true picture of the whole population, or a whole sample. We get the whole mean from that. It uses every data value. But if we're having to put in every single data value, the probability of us putting in one wrong can go up, right? Because if there's 300 numbers to type in, and a lot of them are 38, 38, 38, and then there's one that's supposed to be 38 again, and I type in 83, it's going to throw it off. Okay, so things can go wrong when we're using every data value, but it is good. Also, the mean, extreme values, kind of related to that. Extreme values, what's another name for those? Outliers. Outliers can have drastic effect. I guess that should be effect, not effect. Effect. Drastic effect. We all know this because if we've got an A average in a class, and then we make a 20 on a quiz, it really can drop that average way down. That 20 is an outlier. You're normally making 90s and 100s. That 20 is an outlier, and it can really pull your grade down. It's one of the things that some education folks that are against giving grades below a 50 say, well, if you give them below a 50, it really drastically affects the average. And yeah, it does. But I'm of the opinion you earn what you get. So if you don't want it to drastically affect your average, then don't make that score. because of that, we can say the mean is not quote unquote resistant. Okay. Because it can change based on an outlier being thrown. It's not resistant to just some of the issues. So mean, average, that kind of thing. All right, so some notation things that we need to know as we start getting into some of this stuff are things that you're going to see this on the calculator. We're going to see some things in person. So if you see this symbol, that is the Greek letter sigma. It means a summation. What's a summation? Root word sum. Add them all up. That's what a summation is. Sum of that. X is a variable, normal. It represents the data values. Okay, so if you see the letter X, they're talking about the data values. So summation of X would mean add up all the data values. So sigma X would be add up all the data values. N is or lowercase n, be careful there. Lowercase n is the number of data values in a sample. Capital N is the number of data values in a population. Way I always remember that. If I see a capital N, that's going to mean some certain things to us. Capital N, population. Capital N, big N. That's the way we say it at my house. Big N. Don't put a little N. Big N on this word. Big N, populations are usually what to a sample? Bigger, right? The population of the school, 735 students. A sample, we don't want 735. A sample is going to be like, 100 students. Like that. So little N from a sample from a smaller group. Big N from a big group, that's a population. Okay, that's the way to help you remember that. So when you're looking at a problem, if they use the notation big N, they're talking about the population. If they use the notation little n, they're talking about a sample. And that's going to be important as we move through chapter 3. Okay. X bar with a bar over the top, just a straight bar on top, not squiggled or anything like that. X bar is the mean of a sample. The mean of a sample, X bar. The Greek letter mu, I'll try to write it beautifully. It's kind of like a cursive U, but the front kind of comes down a little further. You normally would make a cursive U like that. I'll just tick that down, and you got mu. And that is the mean of a population. Okay. So if you're reading a problem and they give you some information, they say X bar is equal to this number, that's the mean of a sample. If they say mu equals this number, then you're talking about a population. So recognizing the differences in those, important notation wise. Now summation, it's sigma no matter what you're talking about. X means the data values. That could be population or sample. Lowercase n, big N, X bar, mu. Those are the ones that we need to differentiate between population and sample. So make sure you know that. When you're talking about X bar, the mean of a sample, that's this notation, sum of the X's divided by lowercase n. Mu is sum of the X's divided by big N. Okay. sample, population. Sample, population. Know the differences in those. Pay attention to the problem because all of the numbers are going to look similar, but the notation is going to help you keep it separated out of that. Okay. So let's look at just a quick example of finding the mean. And I'm going to show you. We'll do it by hand, and then we'll get the calculator to crank it out for us. So here's a sample. I'm telling you, it's coming from a sample. The word problem that you obviously have in the practice, it will tell you a sample has these data values, or it will say, we conducted a survey, the population has these values, and they'll tell you what you're dealing with there. So here's our sample: 22, 26, 22, 24, and 23. Very small sample. Would definitely be easy to find the mean of that without using the special functions of our calculator. Add them all up. 1, 2, 3, 4, 5. That's 100. And 810. 117 divided by 5, right? And get that. So summation of x divided by n. It's x bar we're finding. 117 divided by 5, which equals how much? Say it again. 23.4. Wonderful. Now, with the graphing calculator, obviously you're probably going to have more than 5 numbers out of that to deal with. So, and you're probably going to do more than just find the mean. So I'm going to show you how to use the stat function on your calculator to help you get there. So stat, go to edit, or enter lists. Okay, I've got a frequency table in here that I'm going to delete and just do a set of data. Okay. So I want to delete list 1, list 2. So to do that, arrow up to where it says list 2, hit clear, enter. Over here to list 1, arrow up till L1 is highlighted, hit clear, enter, and it empties the whole thing. Okay, and then I'm just going to put in the data values from that sample: 22, 26, 22, 24, 23. All right. From there, I'm going to hit stat, and I'm going to get it to calculate some things for me. And I'm going to use one variable stats, the very first option there, one variable stats. And that'll crank a lot of things. So I'm going to hit enter there on number 1 and list the list of the data values. Mine's in list 1. So I want to make sure that says L1. Okay. If it doesn't say L1, you're going to hit second and the number 1 to put L1 there. Frequency list, we'll get to that in a little while when we have a frequency distribution that we need to find the mean or something of. Okay. So there's not a frequency list. We've got a list of data values. So leave that blank. If it's got something in it, delete it. Okay. So just press down and hit clear or delete on that spot. Okay. And then press calculate and it punches out some stuff for us. Okay. X bar, what's that notation for? Mean, right? Mean of a sample, right? Sigma X, 117. That's what we added them up to be. We did that by hand. There's only 5 of them. That's easy to do. When there's 55 of them, that's not so easy to do. Okay, so this is where that's handy. Sigma X squared, that's squaring every data value and then add them up. That comes into play in some other formulas. Here we have standard deviation. Those are what those two are. We'll get to that in a little while. Those are not measures. Those are measures of variance, not central measures. But S, that's a sample. That's the lowercase sigma there. X is for a population. N is 5. The minimum is 22. We can press down, see all this other information it gives us. Gives us the median. Gives us Q1 and Q3. What are Q1 and Q3? Y'all remember those from way back? Maybe junior high is probably the last time you may use those. Maybe algebra 1. Y'all remember doing box and whisker plots from way back? You remember seeing those? Pots and whisker plots. They're the ones that you had a box, and then you had whiskers on the sides, and then there was usually like a line in there. I remember doing something like that. It's been a while probably since you did that. Q1 and Q3 are these spots out of that. And then this was where X bar was the mean. And these were your maximum value, your minimum value. That's why the one variable stats gives you those, because it makes, making the box. If you can get that, box and plots really super easy. The one variable stats, because it gives you Q1, Q3, the medians in the middle. Notice that this one, the median, is real close to what our mean was. That'll come into play later. So, being the difference out of that. So, one variable stats, really a handy thing, can be great for just quickly calculating some important values for our data. Okay. Now, next thing I want to talk about with measures of center is the median. What is a median? Number in the middle of ordered data. Okay. Sometimes you will see this. Did it go off? Sorry. Thank you. Notification. There we go. All right. So the median's number in the middle. You got to have the data in order. With the one variable stats, you don't have to put it in order when you put it in. When you type in the values, you just got a list of data. I didn't put mine in numerical order. It'll find the median for you, because it'll, in its nice infinite wisdom of the calculator, will reorder the data and find the median. The notation that you will see for that is X tilde is what that's called. How do you say that? X tilde. It's an X, and then instead of a straight bar means mean. Median is going to just be that squiggle. On the keyboard, on a QWERTY keyboard, it's the one right beside the escape key right there. That little squiggle that you hit shift, and then that button, and that's how you get tilde. But X tilde, that means the median. We'll just say the median. I don't ever say X tilde. I say, what's median? But that's the notation that your book uses for median. Okay? So median, measure of center. Mode. Y'all remember what a mode is? What is it? Okay. Occurs most. When you're dealing with data sets, either from samples or populations, you can have a bimodal set. What does bimodal mean? How many modes are there? 2. Okay. And then we'll call it multimodal. You could have 3 modes. You could have 4. You could have, depending on how big your data set is, what's going on, you may have more than one mode out of that. Bimodal, is pretty common. More than that, not as common, but possible. So multimodal, anything more than 2, which is called multimodal. Or do you have to have a mode? No, there doesn't have to be one. There could be no mode. If everybody, if you got a set of data and everybody occurs once, then there's not a mode. If everybody occurs twice, there's really not a mode. Okay, so if we're looking at a sample and there's no 1 or 2 values that occur more often than the rest, then there can be no mode out of that. All right. There's another measurement of center. Next one you may not have encountered is mid-range. Mid-range. This one's probably a new one on you. You've done mean, you've done median, you've done mode. Mid-range is you take your minimum plus your maximum and you divide them by 2. Now I use the not equal to symbol there, that mid-range does not equal median. That doesn't mean that they won't be the same number sometimes. It just means they aren't the same thing. Okay? Median is from an ordered set of data. It's the number that's in the middle. If it's an even set of data, even number in for the sample or the population, we got to take the 2 that are in the middle and take the average of those to get the median. The mid-range is you're taking the minimum value plus the maximum value and dividing by 2. That's how you're going to find the mid-range for either a sample or a population. Mid-range, not the same thing as a median. Okay. Median, what's special about a median? Now we can compare these 2 things. Contrast them. What's special about a median for any set of data? It's in the middle, right? Mid-range sounds like it should be in the middle too, right? But a median has the exact same number of values to its left and to its right. Where a mid-range takes the minimum and the maximum value. If our minimum happens to be an outlier, then we may not have the exact same number of values to the left and the right of the mid-range. A median it's sitting right in the middle. There are 6 people to the left, 6 people to the right. That's the median. But a mid-range, you're taking the minimum score and the maximum score and then adding those up and dividing by 2. It may be the same number as the median. If it is, then you probably are sitting halfway in. But it may not be the same number, and it doesn't mean that you have the exact same number to the left and to the right of that. Okay, so a mid-range, different than a median, although a lot of times, especially with normal data sets, they're the same number. Okay, but they don't have to be the same number out of that. All right. Those are some of our measures of center. Let's look at some rules that we need to stick by for rounding, because not everything is pretty and nice. Rounding rules for measures of center. Calculated values. For calculated values, we're going 1 more decimal than the data that we're given. Okay, what are the calculated values for measures of center that we could have here? Okay. Mean is definitely a calculated value. Okay, so if everything is an integer, like our example A was, everything was an integer. Our mean, we rounded it, or we didn't round it at all. It turned out to be 23.4. But if it weren't a nice terminating decimal, we need to round it to 1 decimal place. Okay, for the mean. What's another one that can be calculated from the ones we've talked about? Mid-range definitely is a good calculated value. It's got its formula, max plus mean divided by 2. Round to 2 decimal places, or 1 decimal place if it's one more than what your data has. So if you've got a table that's got all the data in it, see what everybody in that has, and you go 1 more decimal place than that. What is median calculated? We talk about mid-range and median. Sometimes, always, or never. Sometimes it is. If it is calculated, then what do we round it to? one more than what you've given. Okay? Median is sometimes calculated, but not always. That's nice when we got an odd number of data values and it's just the one sitting right in the middle. But when there's an even number of data values, you got to calculate that. So be careful of that. So calculated values, any of the things you're going to have to calculate, you're going to one more than the data values themselves. What measure center have we not talked about that's not calculated? That we've talked about already. Mode. Do you ever calculate mode? No, because mode is just which one occurs the most, right? So you're not ever going to calculate that. So it's going to be the same as data values. If everything has one decimal place, the mode is going to have one decimal place. Where all of the ones that we can calculate could go 2 decimal places. Okay? So mode should be always the same decimal places as your data. Okay? All right. Let's look at chapter 2 stuff with this stuff. Okay, so if we've got a set of data that's all of the numbers that from a sample, finding the mean, one variable stats, that's easy to do. Okay, what if you're given a frequency distribution? Okay, so but what do you plug into the calculator? What information? Now, that's where we got to get. Okay, with just a frequency distribution, if we want to find the mean, the first thing we got to do is find the class midpoints. And then create the frequency table with midpoints and frequencies. By hand, we will take that frequency times the midpoint and then sum all of those up. Okay, so multiply midpoint times frequency and sum divide total frequencies. Okay, so for example, we'll call this example B. Let's go to that IQ stuff that we used all through chapter 2. Here's the frequency distribution that they give us. This is what the frequency distribution in the book looks like. Okay. Here are our classes. Class width is how much? 20. The same table that we dealt with last chapter. That they just kept using in an example over and over. It's the IQ stuff. Okay, so they give us this frequency distribution for the IQ scores for this sample of 78 people that they sampled here. We want to take and build a frequency table in order to find the mean, or to get our, if we wanted to make a histogram, same process, right? When we're making a histogram, we get the class midpoints too. So IQ, and then I'm going to put CM in that so that we know that's class midpoints. Okay, so what's the class midpoint of? Say again. Is that right? Okay. 60, 80, 100, 120, 140. Y'all agree? Okay. Okay, so do we want rounded or not? Is this a calculated value? $50, 51, 2, 3, 4, 5, 6, 7, 9. Yeah, we don't want a rounded value out of that. 50 to, what are our class boundaries? 49.5 to 69.5, but not including 69.5, right? So if we subtract those two or add those two and divide by, is it still 60? It's funny, right? 59.5. You take your class boundaries, 59.5, right? Okay. So 59.5 is what we want to use. So that would mean the next one would be, yeah, and you just follow suit there. Be careful about that. Did the frequencies change? No, they're all the same. Now, we can take this and we could actually manually do it. We could take 59.5 times 2, get that solution. 79.5 times 33, get that answer, and do that across. And then add them up, divide by the total number of frequencies. You can do that. The calculator will do that all for you in one swoop with one variable stat. So we're going to use the calculator to help us get there. So going to stat again, I'm going to edit. I'm going to get rid of my list 1. And in list 1, for my new stats, I'm going to have my midpoints, class midpoints from my frequency distribution that I'm dealing with there. So 59.5. Oops, 59.5. 79.5. 99.5. 119.5. 139.5. Then I'm going to go over to list 2, and there I'm going to put my frequencies. 2, 33, 35, 7, and 1. And then I've got one variable stats that I'm going to hit. And list 1, that's your midpoints. Your frequency list, where's that at? That's list 2. So how do we get list 2 in there? Second and number 2. And then hit calculate. If we're looking for the mean, which one of those is the mean? Top one, 92.3205, all that stuff. What do we round it to? Okay, so what are our data values? You remember from all that stuff before? I would say 1 decimal place, because I don't think none of our data values when we talked about all this information were half. Like you took a test and you got an IQ of a 72 or 120. You didn't get 120.5. You got 120. Right. So all of our data values from the original thing was one that had 0 decimal places. So we can have 1 decimal place. So our mean is 92.3. Yeah. Back up. Yeah, 92.3. Brain was what was swapped the 3 and the 2. We can get the median should be around 99.5, but that doesn't mean anything as far as all the data out of that. If we're just giving a frequency distribution.
Okay. So when we're taking these means and such, we're using the original data values for the rounding, not the class midpoint.
There you go. Exactly. Exactly. Not the class midpoints. We're going to the original data values. Okay. So if they give you a frequency distribution and tell you it came from a certain table, you might want to flip to the back of that appendix and look for what table it came from to see what those original data values looked at. That's good. All right. All right. So nice use of the graphing calculator to do that. All right. Let's look at one more thing in this section, and that is a weighted mean. All y'all should be familiar with weighted means because all of your grades are figured on a weighted mean. For a weighted mean, the notation for that is summation of the weight times x divided by the summation of the weights. Okay. A great example of this is GPA. I figured your 4.0 scale GPA. Okay. So let's get a frequency distribution here. A's, let's say we had 10 of those. B's, we had 5. C's, we had 2. We had 1 D and 1 F. 12. The 4.0 scale, yeah, college grading scale. So let's just say that's what we've gotten so far. We want to figure out what our GPA is. Most colleges you go to now, I know UT Martin has this, so I'm sure most of the bigger ones have this. We have a thing called flight plan, and you can click your flight plan, and it will calculate all that stuff for you, and then you can have it. You know, if I make this, what do I need? What do I need to make this semester to get my GPA? That sort of thing. And they'll do all the math for you. Because evidently they figured out people can't do math. It's sad, but that's what's going on. All right, so if we're going to find the weighted mean of that, summation of the weight times x, the way that works, how many points is an A worth? 4. How many points is a B worth? 3. How many points is a C worth? It's 2. How many points is a D worth? 1. How many points is an F worth? 0. Why did I put some of the weights? We had 19 scores. 4 times 40, 15, and 4 and 5, so 60. And we'll go 60 divided by 19. 3.16 or 3.2. We go 1 decimal place because all our data that we know of is 1 decimal place, 3.2. rounded value. 3.2 GPA out of that. That's pretty good. That'll keep your lottery, right? It'll take 3.0 to keep your lottery once you go to your hope scholarship. It's 3.0, I think. And if you lose it, you got to get it back up to a 3.0 within a semester. And that's where the flight plan thing is handy for folks, that you can keep it for the next semester, and then you've got to have your GPA back up. All right. In your textbook on page 89, there's some calculator help things that are on that page. It's kind of handy, a reference page out of that. So you might want to either take a picture of that with your phone or something, so that you got it handy if you're having to do, so you don't have to flip back and forth. If you're having to look back at those tables in the back and things. What we're going to work on for this particular section be page 91 through 32. A little more math in this one to do, not so much just informational things. Still a lot of informational stuff here, but a little more math in this section, in this chapter, than there was in last. You got 30 minutes or so left in here, but work day tomorrow as well. There are 32 problems, so it's quite a bit. So.
Back to like the rounding.
Uh-huh.
You wouldn't put there even say where it's not just that one place.
You're always going to go one more place than what your data values have.
It's like,
If it's a calculated value, you're always going to go. If it's mode, I'm around it. Always. They should have been for something as well. The scale, the class width is one. But the tenth number is not
so this one's.
halfway in the middle.
Yeah, 68, close to 69.
The tenth number is not in the middle. There's 20 values, then the 10th and the 11th number have those two. You're supposed to, and when you're doing a histogram, it's supposed to be class midpoints, and then or class or lower class level. You do it. Your calculator can do it either way, depending on how you do the histogram. So, like if your histogram had, let me just like this thing.